In this lecture, we'll see how we can fine tune a generic LLM with a specific dataset to serve our purpose. Pretty straightforward. Three simple steps. First, we'll create the custom dataset. Basically, it would be question and answer pairs that we will create in Colab. Step 2 would be fine tuning the generic LLM using our dataset. Now we will use Gemini 1.5 flash tuning model from Google as a base model to fine tune. This we will do using Python code in Colab. And finally, once our fine tuned model is ready, we will test the fine tuned model. This testing will also be done using Python code in Colab. Now, one thing we are assuming is you have already generated the API key for your project in Google Cloud. Remember the way we generated it in RAG implementation example using Google AI Studio? We are assuming that key is ready with you. Okay, let's dive in. All right, now we'll see step 1 and 2 together. So for step 1, what we said was we will create a sample dataset. Here we have created a dataset with question and answer pairs. So you see the text input is always a question. For example, what is GenAI? And the output is always an answer for this question. Now you can notice few things. All these questions are GenAI related because let's say we are creating this fine-tuned model as a backend for a chatbot application which answers GenAI related questions. Another thing to notice is in each output, the answer always starts with good question and always ends with all the best. Now, this is again on purpose. We want to see if we fine tune the model using this data, does it pick up the style of answering the question? Because as we saw, fine tuning is essentially used so that the model can learn your own specific style for your own domain. Also, for our example, we are giving few sample Q&A pairs. But in real life, the sample size or the dataset would be much larger. And we also have ability to upload such a large dataset. We need not have it only in our Python code. Here, for just for the example, we have taken it in Python code. Okay, so we have the training data set ready, and then we will write the Python code around it to actually get a base model, which is the Gemini 1.5 flash model, and then fine tune that base model with our training data set. So we are providing our training data set, and there are some other parameters like batch size, learning rate, etc., which are important for fine tuning the model. Let's run this code and see whether we are able to fine tune the base Gemini model with our dataset. As you can see, it does take quite a bit of time for the base model to be fine tuned with your specific dataset. And that's the reason we have the operation bar here to see the progress of our fine tuning. Okay, after about a minute, we got our output back. So now you can see the base model was fine tuned and a new fine tuned model created for you. You can see the name of the model here. This is the name of this is important because this is your fine tuned model. Let's copy the name of this model. And now the final step of querying our newly created fine tuned model and see how it responds. Here's the simple code. We again use the same API key. Then we get our fine tuned model that we created in step 2. That's the reason the name of the model is very important. There are also methods to query what fine tuned models you already have. So here we get our newly created fine tuned model, and then we query the model with a question like, let's say, what is supervised learning? And we'll see what the result is. Just for reference, let us paste the sample data that we had used to fine tune the model. Let's run this now. And here we go. Now we see here that the fine-tuned model answered the question in a style which it picked up from our sample dataset. The question, what is supervised learning, was not part of our dataset. What was part of the dataset was what is unsupervised learning. So the answer to this supervised learning is where the model is trained with labeled datasets, is what the model generated from its previous training. But the style is one which it picked up from our specific fine tuning. Hence, it started the answer with good question and ended it with all the best. This shows we can fine tune a model for our specific needs and domain. Let's see if we ask a random question which is not related to GenAI. For example, what is capital of France? Again, you will notice the model's answer had good question as the starting and all the best at the end. The style it had picked up from our dataset. Another thing, from our dataset, it understood that everything would be related to GenAI. And that's the reason it added LLM model at the end of its answer, which is an unintentional output of what we were trying to do. And these are the overfitting cases that you should watch out for. So we saw a very simple example where we could fine tune the model and the model adopted our style and tone. With this, now you are enabled to fine tune models for your specific use cases and domain.